Hi, this is the second lesson of topic 2 on forces and motion. And in this lesson, we're going to learn about circular motion. Circular motion is a really interesting phenomenon and we see it all around us. Every time a car goes around a roundabout, when an electron rotates around the nucleus, or even a planet goes around the sun. You could actually try swinging a glass of water or a bucket of water around your head and you'd find that no water actually falls out. That's if you're moving your hand fast enough. It's really interesting, and in this lesson we're going to learn about why that is. So first think to yourself, what's the equation for acceleration, and what's the difference between velocity and speed? Pause the video and think. So acceleration can be defined as change in velocity divided by time. And velocity is considered a vector quantity, whereas speed is considered a scalar quantity. So velocity is simply speed, but with direction. Let's take this concept and this idea a step further. Here we have the London Eye. Think to yourself, are the pods on the London Eye moving at a constant velocity? Are they moving at a constant velocity? Velocity being the key word. And why? Pause the video and think. Now before we get into this question, draw a quick sketch of the London Eye and add arrows to indicate the direction of motion of the pods at the top, at the bottom, and on the sides. And in this case, the London Eye is moving in a clockwise direction. But focus on those individual pods. How are they moving? Pause the video and have a go. So, the pod at the top is moving in this direction. The pod on the right is moving in a downward direction. The pod at the bottom is moving in this direction, and the pod on the left is moving in an upward direction. So as we can see, the direction of motion of these pods is constantly changing. As its direction is constantly changing, its velocity is also changing. As its velocity is changing, its acceleration is also changing. So these pods are constantly accelerating. So just to recap, even if the pods are moving at a constant speed, they may be moving at 5 meters per second at a constant speed, the velocity of the pods is constantly changing because they are constantly changing direction. So the pods are actually accelerating. So if these pods are actually accelerating, why do they not just fly off? If we look at this diagram, we can see that the pods are connected to the center of the London Eye through these steel strong wires. In fact, there is a force of tension holding these pods towards the center, pulling these pods towards the center. In this case, this is known as the centripetal force. So for any object moving in a circular motion, there is a net resultant force acting towards the center. And this resultant inward force is known as the centripetal force. The centripetal force is present in all circular motion, and this is the resultant force acting towards the center. In this case, it's tension, but the centripetal force could be different in different cases. Let's consider these. Here we have a car traveling around a roundabout. Here we have the moon orbiting the Earth, and we have a bucket of water swinging around a person's hand. Pause the video. Try and identify the centripetal force in each of these cases. Pause the video and have a go. So, as we can see from the diagram, in the first example, the centripetal force is friction, and this acts upon the wheels and provides a centripetal force towards the center of the roundabout, allowing the car to move in this motion. For the moon, this is gravitational force, or the force of gravity, and this acts on the moon towards the center of the Earth. And finally, this, like the London Eye example, is the force of tension in the string. And this allows the bucket to travel in a circular motion. That's it for this lesson. I hope you found it useful. If you have any questions, please do ask.